Okay, so let's start our class. Okay, I think we in our last class in lecture 3 we started the ideal gas, right? So, and I think I completed what form we will use for our fluid mechanics class. Did we complete in your session that P equals to rho RT? Okay, good. So what we will do, we'll start from that point. Before that, just a quick review. Can you remind me what was the definition of ideal gas? Like when we can call a gas an ideal gas? What are the characteristics, or what is the main characteristic for being an ideal gas? You can check your class lecture 3 if you want, and tell me what will be the definition for ideal gas. That means that molecules are spread far enough that they don't have any attraction in between them. And we also said there is nothing called ideal. There must be some sort of attraction, but maybe that is not strong enough to, like, what should I say, that we can consider the gas as ideal, because that maybe the bonding is very weak or something like that, right? So that's what we discussed. So in the equation, we said that we worked on the board last time. Today I will write down again just to do a quick review. And we also said that the appendix A I gave you in last class. Do you have that copy with you? Okay, so we will use that maybe today. And that copy has the R values for all the, like, gas, ideal gas we can use. Okay, if it's not there in that table, you can find from internet or from any other fluid mechanics books, and it should be same. So if I write down that again, the equation was rho RT, right? This one. And I'm telling you one thing, one of the common mistakes you will do in the test one, you will mix up with that P and rho. They are not same, right? Though they are looking like they look similar, but they are not same. One is pressure, another one is what? Yes. You are not seeing that on your screen? Oops. That's a bad news. That means it's not recorded. Okay. Are you seeing now the screen? Okay, thanks. Okay, so P equals to rho RT. Can you remind me what was the T? Absolute temperature. Good. What was R? Ideal gas constant, and we can get that from appendix A. What is rho? Density of gas, right? And do you remember the P? What was that? Absolute pressure. Good. So it is not any kind of pressure, it is absolute pressure. Now we already know what is absolute temperature. Today we will try to learn what is absolute pressure. Now from the absolute, if there is any absolute, obviously there will be something called relative, right? And when we say relative, what does that mean? We measure something against what? Some known standard, right? If we measure something with a known standard, that is called the relative or gauge pressure. So that's what we will do today. We will try to learn few different types of pressure And there is a mistake that should be pressure, not the temperature. Okay, so the absolute pressure is when you suck out all the pressure from a container, there is absolutely nothing, right? It's just empty, not air particle, nothing. So the pressure of that container is actually the zero, which is called absolute zero pressure. And you measure, if you measure something from that that pressure, that is actually the absolute pressure. Now, we are saying there is another type of pressure we will use, which is called gauge pressure or relative pressure. Now, what value of pressure we will use as a standard for gauge pressure? What is the most common gas we encounter every day, every second, every millisecond? Air, right? So the air pressure at 15 degrees centigrade or like this type of temperature, that will be the standard for the relative scale. Okay. So if we measure the temperature from this point, that is the free atmospheric pressure, which is 101 kilopascal or 14.7 psi. That is the standard value here. And if we measure something with respect to this scale, that will be the gauge pressure. Now, though we are surrounding with the pressure with that big, like 101.3 kilopascal, are you experiencing anything like any pressure on your mouth or any and anything? No, right? So that's why it's a good standard and it's a known value. So we can find that from anywhere. It's a known value, it's a good standard and it feels nothing. So we will consider these as a zero pressure, as a gauge, like zero gauge pressure. But do you think it is actually zero pressure? It's not. There is a value, 101.14 psi, something like that. But just for standard purpose or scale, like if we want to introduce another scale, which is easier, we will consider this one as a zero and any pressure above this or below, like if we measure something, that will be the gauge pressure. Do you think the absolute pressure can be negative? But gauge pressure, what about that? Gauge pressure can be negative? Yes. So gauge pressure can be negative, and that time we usually call that vapor pressure. But absolute pressure, that can't be negative because that is the absolute zero. There is nothing below that. Okay. So let's go to the next slide. Just to give you the value, at 15 degrees centigrade, the value is 100.3 or 14.7 psi. And if we measure something from this scale, that is called the gauge pressure. Now, are you seeing the line at the very bottom? If we don't specify anything and just say pressure, it will be always, always, always gauge pressure. But if we want to do something with absolute pressure, we will mention that. So if you see the word pressure, automatically think this is the gauge pressure. We don't have to do anything with absolute or anything. Okay. Now, for the ideal gas flow and for some other purpose, we need to use the absolute pressure. And for most of the cases, we need to use the gauge pressure. What do you think? Is there any way we can connect gauge and absolute pressure? Is there any easy way we can do that? What do you suggest? If I write down P absolute here, okay, this line here, okay. So P absolute equal to P gauge. What is the best way to connect these two? What do you think? This is the P absolute, and up to this point, How can we connect? Or what is the best way to connect absolute and gauge? Gauge pressure is what? It is measured from what point? What we are experiencing right now, which is the atmospheric pressure, exactly. So if I add just the atmospheric pressure with gauge pressure, that is basically the what? Absolute pressure, right? So this is the relation between these two, and we will see, we will use that for some certain application, not for all the applications. And whenever we need to use that, you will see some notes or something that you need to use the absolute pressure. Okay? Otherwise, we are always using the gauge pressure. Are we good? Are we a little bit comfortable with two types of pressure and everything? So we already know two types of temperature. Now we know two types of pressure also, right? Good. Since we are good, let's do one class example where we will convert some pressure and some pressure both. Okay? All of you have the class example 3 with you. Now, can anyone read the class example 3 loudly so that everyone can hear? Read the class example 3 loudly. Do I need to pick someone or you will do that voluntarily?
How much fuel do you think?
Pounds per slab degree ranking, right? Thank you very much. So what they are saying, this is a tank right now which is empty, but the volume of that tank is 500 feet cube and it has some weighs 400 pounds. So they are asking you to find the weight of this tank when it is filled with hydrogen under a certain pressure, and the pressure gauge should read what? 3500 psi, right? Okay, so that's what we need to find. So let's write down all the known values and unknown values and how we can connect those. Okay, so you will help me to write down all the given values. What is the very first given value here for this question? The volume of the empty tank, right? So volume empty equals to what? 5000 feet cube. What else? From back, can you see my handwriting clearly? What else? Okay, so weight empty maybe 400 pounds. What else? What else do we know? Gauge, they said that it's already gauge pressure, so I will write down P gauge 3500 psi and so P atmospheric 14.7 psi. What else? Temperature 70 degree Fahrenheit and gas law 2466 feet pound slug degree. Right? And what we need to find? the weight of the tank filled with what? Hydrogen. Okay. So what we will do, at first we will find the weight of the hydrogen, and then if we add with the empty tank, that's the total weight, right? So that's what we will do. Now, there are some given values here and one unknown. And before starting this problem, please tell me what unit system we are using here. It's FPS or SI? It's FPS or SI system? FPS system, okay. So we will use the FPS system here. Now, they didn't say anything about using the ideal gas law here, right? So how do you know that which equation you need to use or how to connect the knowns and unknowns? What is the best way? How to know? It can be same during a test also. Maybe I will not say anything, use ideal gas law or something, but how do you know that it's ideal gas law problem or something? Say it again. That is a very good indicator that R is given. It can, but sometimes maybe it will be unavailable. You have to find that from the table. One of the best way is hydrogen. We know this is ideal gas, right? And from the given values, you will know that, okay, we need to find the weight of the gas. So temperature is given, pressure is given. Obviously, PV equals to nRT or P equals to rho RT. That should be the equation because in that equation we have pressure and temperature, right? So that's how you will know that this is an ideal gas law problem. Okay. Okay. So we already know that for solution we will use ideal gas law with FPS unit system. So solution will be P equals to rho RT. Okay. So for rho and sorry, for P and T, are we using the relative one or the absolute temperature and pressure? What do you think? In this equation, we are using absolute or the relative one, or gauge pressure? Go back to the first slide where we discussed what type of pressure and temperature we use for absolute gas law. Sorry, ideal gas law. It will be absolute pressure and absolute temperature, right? Now the pressure was given, which is gauge pressure. How can we convert gauge pressure to absolute pressure? Is there any way we can do that? Add the atmospheric pressure. Yes. So that's what I will do. 14 point. That's what I will do. 14.7 plus 3,500 pound per square inch equals to, I don't know anything about rho, so I will keep that as unknown. What is the R value here? 24660, right? And the unit is feet pound slag degree Rankine. Now the temperature is given in what unit? Do you think Fahrenheit is the absolute temperature unit or the standard unit? It's not. For FPS unit, what is the standard unit for temperature? It's Rankine. Okay, good. How can we convert Fahrenheit to Rankine? Remember, I gave you one page of some conversion factor. You can go to that page and at 460. Okay, great. So 70 plus 460 degree Fahrenheit. Oh, not Fahrenheit. Right. Do you think it's correct? Like, did I write down everything correctly here? Okay. So let's do the second line. So 3514.7. So it will be 13. Uh, 14.7 pounds. I think I made a mistake here. That should be inch square, not the second square. I don't know why I wrote in, like second square. That should be inch square. Now, inch is not the standard unit. What unit I should use? What is the standard unit of length? Good. And 1 foot equals to 12 inch. So that's what I will use, or I will convert. Right? Now, I have row here. I have 24660 feet LDF slab multiplied with 460 plus 70 is what? 530, right? Okay. Now what I can do now, I can cancel some unit, right? I can cancel this ranking. I can cancel this inch square, and from both sides, since everything is in multiplication form, I can cancel pound, right? So let's write it down. What is the final form we have here? So 35147 multiplied with 144 feet square, row 24660 pound feet per slab. Okay. Now, what is the only unknown here in this question? The density. Is there any way we can rearrange the equation such a way that density should be on one side and everything else should be on the other side? Okay, let's do that. So do that on your copy. I will wait 1 minute and then I'll write down so that you can match. So keep the density on one side, maybe on left side, and move everything on the right side. Okay? Can you do that? Okay. Try to do that. If not, I will write down that within a minute. So it will be row, something like that. Maybe I will go to the next slide because it will be a little bit clumsy here. So all of you are done up to this point? Okay. So I will write down row equals to move everything on the other side. So we had 3514.7, 144 feet square. Now if I move everything from the other side, it will be what? 1 over 24450. Do you think it's the correct rearrangement I did or I made some mistake? That, yes, two. Oh, that is the zip code for Lexington. That's that's 24660. Now it's correct. Okay. Can you give me the value for row with proper unit? Since it's gas, the density will be very small because the weight mass of the gas is very small. You should get something 0 point something maybe. Anyone has any number? 0.0387. Anyone else? You got kind of same number? 0.0387. And what will be the unit? You can get that from the unit left here, slag per feet cube, which is the unit for mass and the volume, right? And we also know density equals to mass times volume. Sorry, mass divided by volume, not the mass. Okay, now we know the density, but we are supposed to find what? Weight of the hydrogen, right? How can we find that? Density is very much related to mass, and weight is related to mass also. Is there any way I can find the weight from here? Like mass times gravity is the weight, right? And how can we find the mass? Yes, good. This one, right? Okay, now we got density 0.0387 slag per feet cube. What is the volume of the tank? 500 feet cube. And what is the value for G in FPS unit? 32.2, and the unit should be feet per second square. Okay, now again, I can cancel this feet cube, and this is again mass times gravity, MA, which is the weight. So, what will be the final answer? And what will be the final unit for this one? Anyone got a number? For this one? Yes, before adding the tank weight, what number you got? 623 pounds. Anyone else got similar to that? 623. Okay, those who are getting some sort of number close to 623, raise your hand. Okay, 1, 2. We have 16 people. So I will wait 2 more minutes. to get that the answer so that everyone can get some answer. And once you are done, just raise your hand and tell me what number you got for this question. You got 623, 623, you got 623, okay. You got 623, okay. 2, okay, what about this part? 623, okay. Yes, that is actually the answer, 623 point, I got 623.458. Now that is the weight for the hydrogen only, but they are asking you to find what will be the weight of the tank when it is filled with hydrogen. So what will be the total weight? The next part is very easy. We will just add 458 with 400, right? And that will give you 1023.458 pounds. Good. Now you are ready for homework 1, because for homework 1 you have to solve one question similar to this one. So if you, after going to your room or whenever you try to attend homework 1, you should be fine, because for homework 1, now you know everything how to solve that one. Okay? Okay, those who are done, you can take 1 minute break. We will, don't go anywhere. We will start again. Those who are not done, please complete this class. Okay? I'll keep that slide open. So we will cover one more topic today. We have 10 minutes. So I will start the vapor pressure, and then if we get time, we'll start the cavitation. Now for the vapor pressure, what do you think? What is vapor pressure? What is vapor pressure? From the name, what do you think? The pressure created by vapor, right? Now, how can you create or make vapor? What is the best way? What is the best way you can make vapor from in liquid? Say it again. Boil water. That means you are providing some heat energy, right? Yes, exactly same. Exactly, that is the thing. That's what we will discuss in vapor pressure part, like how the vapor, like how we can define vapor pressure and what is the mechanism that is happening when we get the vapor pressure. Okay? So everyone's done. All of you got 1023, something like that. Okay. So the next one is vapor pressure. As you already told me, we can get vapor by applying some heat. And heat is one kind of energy, right? So when, suppose this is a tank with a closed lid here, and if you apply some heat energy or increase temperature, what will happen? The molecules near the surface, obviously with extra energy, they will be able to break all the bonding in between the particles, and they will try to move on the upper direction, just like that. Okay. So that's what I just wrote here in Word, what is happening here. So if you apply temperature, they will have enough energy that they can break their molecule bonds between the molecules, adjacent molecules, and they will leave the surface or evaporate into the vacuum space on the tank. Now the top part is already closed, so they can't go anywhere. What will happen? They will go up, up, up. At some point, they have to stop, right? And after a few time, they will get condensed into the pressure, right? So what will happen? A number of molecules will be evaporated after a few minutes or few hours, depending on the temperature you are providing. Some of those evaporated molecules will get condensed, right? And if you continue the process, at some point there will be an equilibrium. If I ask you to define equilibrium in that case, what do you think? What will be the equilibrium condition? What will be the characteristics of that equilibrium condition? Like when you can say that equilibrium is here. When the number of evaporated molecules will be equal to you have to respond a little bit. The molecules going upward will be the molecules coming downward, right? That's why it will be the equilibrium, and that's when it's called the saturated or saturation, when the number of molecules that evaporate from the liquid, the number of molecules that condense. Okay? And all the time, all of these molecules, the pressure they are creating on the wall or the top space or something, that is actually the vapor pressure. Okay? In next slide, I put a more formal definition of vapor pressure, but you already know what is actually the vapor pressure. So basically, when the red particle, like red arrows molecules and the blue arrows molecule will be the same, the number of those particles, it will be the equilibrium condition of the saturation, right? Okay, so if I want to define the vapor pressure, while these molecules are moving in the tank, they will bounce off the walls of the tank and liquid surface, creating the pressure in the tank. This pressure is called the vapor pressure. Basically, in this process, all the pressure they are creating on the wall or surface, that is the vapor pressure. And since this is the pressure, the symbol will be again P with a subscript V, V for vapor. What will be the units or units? It's one kind of pressure, so it will be PSI or say it again, pascals, yes. So it will be either Newton over meter square or pascals or PSI or pounds over feet square. Like anything, force over area, that will be the unit for this pressure. Right? Now, if you go to your appendix 1 copy, when you open that, you will see for different temperature, the water has different vapor pressure. Are you seeing that? The second page, page 842 and 843 for appendix 1. So, did you get that? Page 842 and 843. Okay. So I copied from that page. This is the page. And are you seeing that with increasing temperature, the vapor pressure is increasing or decreasing? For 0 degree, it was 0.681. With 100, it's 101 kilopascal, right? That means with higher temperature, higher vapor pressure. Why is that? Because if you apply more temperature, that is more energy you're giving to the molecules, they will be moving more frequently and more number of molecules will get, right? They will create more pressure. Now, just to remind you or connect some dots, 101 kilopascal. Does this value look familiar? 101 kilopascal. That is the atmospheric pressure, right? And that's why in this situation, now we are in the atmospheric pressure situation, right here. And that's why if you apply 100 degree centigrade temperature to the water, it will start what? Boiling. But it will not be the same every case because for different temperature, vapor pressure is different. It's only because at 100 degree, the vapor pressure is 101 kilopascal. That's why water will be boiled here, but not on top of the mountain or inside some point in the earth. There will be different boiling temperature. Okay, so that's what I wanted to connect here. So higher temperature, higher vapor pressure because you already know you are increasing the temperature, more molecules will get evaporated and condensed. And that's why they will create more vapor pressure. Okay, so I'm not starting the cavitation. I will start that next class and I will stop here. Just to remind you, vapor pressure is very important because at this temperature, so at that pressure, water will start boiling. Okay. So working on your homework one. If you have any question, ask me on Friday, email me, anything. I will try to help you. And I will see you on Friday. Thank you very much. Yes, I will do that. Yes.